Hello, I'm Dr. Gleisner and I'm talking about electronic structure in this video, and all we need to really do is to be able to draw some circles and some crosses and some dots. And basically the whole thing is probably best learned as a sort of game with very straightforward rules. So what at most you need to do is be able to draw a nucleus, and there it is. We're not really bothered by the details of neutrons and protons. And then you need to draw some circles around that. You may not need 3 or even 4 circles. It depends on how many electrons there are, because at the center you've got the nucleus with the neutrons and protons in it, and then what really counts are the number of electrons. So let's say you've got element number 11, which is sodium, and that is usually the example given, and it is given in the specification as well. And that means you've got 11 protons, and in a neutral atom of that element you've got 11 electrons. So where do you put those 11 electrons? And this is the very simple game that you've got to learn the rules of. But I will just flip over to a different window because I've got a much nicer picture here. So again, you don't really need the dot in the middle, but there we are. Okay, so you've got 11 electrons to accommodate. You always start with the first shell, because these circles are called shells, and you put the first 2 in on that shell. And the idea is that the electrons are closest to the nucleus, they're more strongly bound, and they also repel each other because they're negatively charged. So they can't accommodate, that first shell can't accommodate more than 2 electrons. The next one out is further away, and because it's further away, it can accommodate more electrons. And in fact, the number of electrons it can accommodate is 8 at maximum. And you, again, until you have 2 in the first one and 8 in the second one, you don't start on the third shell. And you can now add the electrons up. That's 2 plus 8. 2 plus 8 is 10, and we have 11. So the last one can go anywhere on that third shell. Now, the reason why I've basically paired these up is because later on it is much easier to count them for like an examiner, and later on as well we will learn that there's a reason why I've paired them up, and that can make your life a lot easier. Okay, so that's pretty much it for this video. Maybe I should add that the lowest shell there, the nearest to the nucleus, is the lowest energy. That means the electrons are most tightly bound, and then you've got higher energy levels in the second and third one. And that is what I was talking about with regard to spectroscopy. I should also add that the maximum number of electrons that you will ever have to accommodate is 20. So how many shells do we need at maximum? Well, if the first 20 elements are the ones we've got to worry about, then calcium is the last one, because calcium is element number 20. So again, you start with your first with your dot, and then, because I've done this many times, I've drawn 4 already. So in the first shell, yes, we have 2 electrons, and then we have got 8 in the second one, and then we've got 8 in the next one, and ooh, you can see my drawings are always beautiful. So 2 plus 8 is 10, and plus 8 again is 18. That means we have got 2 electrons left, and we can put them wherever we like. I tend to put 2 single electrons on the opposite side of the circle, but there we are. That's just me. Okay, thanks very much, and see you in the next video. Okay, so some rando on YouTube challenged me to teach people for free, so I'm doing that now. GCSE, A-level, chemistry, physics, whatever you like, let me know in the comments, like and subscribe. Thank you.